All right, everyone. I am going to go over today one of the biggest questions we always get is, how much mileage should I be running in preparation for selection, buds, whatever it may be. So what I've done is I've started breaking down some numbers. This number right here is an available number all over of how many miles does a person run while they're at buds. So this mileage is going to vary very little because that's the official number that the United States Navy has put out on a number of occasions of 806 miles a person, scheduled miles, 806 scheduled miles over 27 weeks of buds plus 4 weeks of prep. So this is 26, 27 weeks, it varies, but essentially it's 27 weeks plus prep. So you're looking at 31 weeks in total of buds, okay? Divide that, right, 806, divide that by 31. So on average, a bud student is going to run approximately 27 miles per week, basically a marathon a week. That's it. Right, that's it. Right? And if we look at the math and go, okay, buds itself is you're only trained 5 days a week outside of third phase. Third phase, you work 7 days a week. So this even helps our numbers even more. So on best case scenario for a runner, right, or what do you want to say, they're going to run, or worst case scenario, they're going to run 5.2 miles a week, right? It's going to go down a little bit. The average goes about 4.9 because, again, the last month we're going to 7 days a week in buds. Buds is 7 days a week, not 5. So again, this goes towards proving our point of mileage in terms of buds is not that high, right? Total mileage is not that high because we're going to get to some weirdness here in a minute. You're going to see down here, okay? So, but we have to also take into account is that, okay, in a 5-day work week, right, of buds, Monday through Friday, one of those days, Monday usually, is a 4-mile timed run. So that 4 miles right here goes into that average. Like we go, well, that really helps us out. There is also during those weeks, 1 day a week. So day 2, there is between a 4 and 6 mile conditioning run that is in buds. Now in second phase, it's known to go up to 12. There's a 12 to 14 mile tennis shoe run that we do, right? There's always conditioning runs that are a little bit longer, but the conditioning buds do not last longer than about 6 miles. They're less. They're just because the loop that they run is a 4-mile loop, and then they'll go past the buds beach, and they'll go down to the demo pits and things like that, and do some feigned stops and make you. But they're really just circling up the class at a low speed, and they don't exceed 6 miles. Okay, so we're looking at, again, if we have once a week out of those 4 days, so we're down once a week, we're down to 4 days. The second week, we're down to 3 days. So day 3, 4, and 5, right? Because if you're doing a 4-mile timed run plus a 4 to 6 mile conditioning run, that's 8 to 10 miles a week that's being taken out of that 26 miles. See? 26 miles on average per week. But we got to remove, right? We got to remove a timed run and a conditioning run roughly to see what our average of conditioning is going to be. So what's remaining for the 3 days left in buds is 16 and no more than 18 miles a week, which comes out to 6 miles a day, right? So if you have 3 days left in buds that you could potentially do some running, because 1 day is a timed run, 1 day is a conditioning run, so we got 3 days left. Well, one of those days is log PT, one of those days is O course, and one of those days is a swim. There isn't a whole lot of time left over for additional running, right? But on average, again, because it's going to average, some days we won't run at all for conditioning and buds, and some days you'll run a 14-miler, okay? So that average we're looking at for average is 6 miles a day for a 170-pound person, right? So we can look at that caloric uptake, and that's still fair. It's very manageable. That's a very manageable caloric uptake because at the same time as in buds, you're going to do 77 miles while you're at buds, right? Which is only 2.4 miles a week, which is less than half of a mile a day. That's it, right? So there isn't this incredible, acute, robust aerobic output over a single day. It's spread out over 31 weeks, okay? And so here's where the weirdness gets, is like you have all these prescriptions of 70 miles a week, which is so absurd. You don't even cover, like in a week. Like think about this, folks. If your job is to run a marathon, you don't run 70 miles a week. So if you're only doing you're only running 5.2 miles a day, why are we saying run 70 miles a week? Why is that impossible? Because the caloric demand for a 170-pound person for 70 miles a week is this word right here, not possible. You are not going to be able to adapt to it. And here's like, well, yeah, Jeff, but. Okay, here's the other absurdity. You're only running 806 miles in 31 weeks. That's it, not much, okay? But here's where the people get weird. They go, well, yeah, Jeff, you run 6 miles to chow every day, which is an absolute lie, okay? Because here's the math. If you ran 6 miles a day to chow, and you did that 20 times over a course of a week, right? Or a course of a month, because you're doing it 5 times a week at, you're over 120 weeks, you're doing it 26 weeks, you're running 3,720 miles just to chow, which is silly. Okay, so what we're looking at is like these absurdities, okay, of, well, are we actually calculating this? We certainly should not be calculating this, because the speed in which this is being covered is not at all the same state of acceleration that is covered here. And so which is why we have you don't see them, but we have the programs up here that do the math, okay? So here's what we're saying is just simply put, if you can't see the math by now, it's like, I'm sorry, I can't hold your hand anymore. For a person that is only running 6 miles on average a day in selection, and the worst case scenario is 6 miles a day. The worst, okay? For a 170-pound man, okay? That's what we're looking at. That's the average. Okay, so how do we take an average person that we know, like roughly a bud student is roughly 170 pounds, and they have to cover 6 miles a day, right? Efficiently cover 6 miles a day at a pace that's reasonable. This is not a reasonable pace down here. This is not a reasonable pace. So we don't calculate that except for total work volume, all right? So it's pretty simple. If you have an average body weight, okay, and you have an average distance, now you can do the average work, right? It's Newton's laws. If I have an average mass in kilos, and I convert this miles into kilometers, now I can find out exactly how much work it takes a 170-pound person to run 6 miles a day in buds. Now that we have a work number, a total work output, which is going to be in newtons, we have that Newton work output, okay? All we have to do is calculate, well, how much does it take a 170-pound man to run a 4-mile test? Now, that is our work output. That's one work output number we're working off of. The second one is, okay, let's say we do 6 miles, and we have to run this pace for 6 miles. And that means our 6-mile run is the highest work output that we're going to do in buds at this weight, okay? So now we have the maximal distance covered. We have the average body weight, okay? We have the distances, we have the times, we have all that, okay? Now from there you just simply calculate, okay, what's my work volume, right? And then you plug in the work volume of this weight and the distance covered in a mathematical equation that tells you how much work that person has to do that mileage. Now, from there, you just plug in the programming that calculates and adds up to those mileage and that work output. It's how track athletes, it's how coaches do this. Because if I have a 150-pound person, the work output is different for someone that's 180 or 190. But they still got to cover this known distance over these known days with these known times, right? We know that's got to be 28 minutes, okay? How much time does it take a 170-pound person to go 4 miles in 28 minutes? That is Newton's law. Once you have that Newtonian law, right, that Newtonian physics, which comes in newtons, now we know. We know. Like, this isn't guesswork. We know that the absurdity of 70 miles is laid out right here. We know that also the absurdity of 30 miles a week, absurdity of 40 miles a week, absurdity, okay? Because you only have to run 5.2 or we'll just say 6 miles a day on average. That is it. At a pace, all right? At a pace that's not robust. And even if we're calculating this distance for time, this speed in which this is being covered is not a detriment to the nervous system, okay? So, whether you want to kind of guess, right, you can do that, but with all of these known distances, known distances, known distances, known distances, what comes with these known distances? We have known times. Like I said, if we have a known distance, right, we have a known time, and we have a known average body weight, right? Then we can calculate all we want for work. Once we have a work output, now we just calculate into the programming of run. It's not that complex. The problem is people guess. We don't guess. So if you're interested in going through these programs and going through our system, here's a look into what we do. But all of this stuff right here, we teach in person, we go over in person, we do the math with our athletes so they understand what we're doing. Like we do a classroom on this, like basically a day or two of it. We go over this. We go over all the splits. So here's the math for the splits. There's the math for the splits right there. It's a different calendar, but right there are 3 examples of splits right there, and those are Newton's 3 laws, okay, that you can work off of to find these work volumes and workloads. All right, so hopefully that was helpful, and hopefully that gives you an idea that you do not have to guess when it comes to work volume. You don't have to guess when it comes to distance. You certainly don't have to guess when it comes to what time should I be shooting for based on that distance and my body weight.